So welcome to day 2 of the NVMe Express sponsored presentations. We've got 2 days of presentations. We've been recording them. All the slides will be available at our website. We're covering pretty much everything NVMe. To do a shameless plug for the subjects that we're covering, we started out yesterday with roadmaps, with architectures, with software and drivers, with transports. Today we're going through 3 sessions of NVMe fabrics. We're going to start with enterprise arrays this morning, which is all flash arrays. We're going to go to NVMe appliances that people can start building with, probably with an Intel processor somewhere, and then JBOFs that are more like, where I start doing bridging directly from some kind of fabrics protocol directly to PCI or NVMe. And then today we'll wrap up with doing interoperability discussion. From both IOL will talk about the testing they're doing, and SCIA will talk about the testing they're doing, and we'll have a couple vendors that do testing talk about the tools they have that people can leverage to build NVMe compliant solutions. This session here is focused on NVMe and NVMe-oF, NVMe in the back end, NVMe-oF on the front end, and building an end-to-end solution based on NVMe for all-flash arrays. All-flash arrays is about $8 or $9 billion market today. It's growing pretty fast. NVMe is coming to this quickly. A lot of vendors have announced products there. And so we'll talk about the benefits of that as these solutions come to market. I'll talk about market segmentation. Brennan Hoff from Broadcom and from the MX part of Broadcom. Then Claude Barrett from IBM will talk about NVMe fabrics, kind of a really good market overview, some good tidbits on how things are architected, important things to know. Then we'll have Mike Kieran from NetApp talk about NVMe over fabrics from the NetApp perspective, as well as some performance data that they have. This is interesting. Now we're getting to the point where we're going to start discussing, what we always talked about, right? When we talked about NVMe initially, we talked about, hey, I can go from a 10 millisecond access to 100 microsecond access to 50 microsecond access in terms of performance, and that's why people did NVMe. Now we're talking about NVMe or fabrics and how I get performance benefits there, and we have some real data we can start showing. So NetApp will show some performance data there on the storage array. Other one is that I'll start talking about NVMe performance benefits on the initiator side. So something that NVMe Express group has done is really focused on building a complete new software stack. And that's pretty well architected, so I can support multiple transports and the like. And I'll talk about the performance improvement we're seeing on the initiator, as well as some end-to-end data. And some of the most important performance improvements we're going to see is really how much more IOPS, how many more applications I can support with the same storage footprint, same storage array. And so we'll get some data there, and then we'll do a Q&A. Talking to the segmentation for today, I try to take as the market matures, markets will always segment, and this is going to change over time. So this is a best guess. Really thinking about, okay, what are the 3 segments that we're covering and that we saw a lot of people wanting to present about. So when we did a call to the NVMe Express membership, which is 120 companies now, I think. This is the groupings that we saw, where we saw enterprise arrays, which is your really NetApp, IBM, ENC, and the like. Then we have server SAN or storage appliances. And these are really where I take a server, I start adding, procedure drives, NVMe drives to it. Maybe I run SUSE on it. Maybe I run some other types of solutions. Maybe I tie this into cloud orchestration. Might be rack-based, may not scale out to a complete data center. But there's lots of people in that space, and then there's a new class of products where really they're either chips, smart NICs, or something like that, where I can start building composable architecture that's low latency, different cost point, different management point, different functionality point. So these are 3 different areas that I think we've seen interest, and this is going to change from year to year. But that's how the sessions are lined up today. So if you're going to go through all 3 of these, you'll be able to get and ask questions about all different parts of this. Today we're focused on enterprise arrays. If you look at enterprise storage market, external market today for block storage, #1 protocol is Fibre Channel. Most of the storage out there is Fibre Channel today for block storage. This doesn't include object. This doesn't include NAS, right? This is block storage. Second one is iSCSI, which is your IP version. And the others would include InfiniBand, SOE, FICON, external SAS, and the rest. And it's growing. In the Fibre Channel market overall, we're seeing reports coming out that will be published shortly that Fibre Channel as a market is growing in 2018 and looks like it's going to grow in 2019. And so the enterprise market's growing. All-flash arrays is really driving this. As people start building up faster infrastructure, faster solutions, take advantage of all-flash arrays. And NVMe is just the next iteration of all-flash arrays. So on that one. Then as they talked about, and emphasize, as we talk about performance, we have three different parts. We have server performance. What's the performance benefit I get on the server? Then I have the fabric, or the front end of the array. And this is before I update the back end of the array to NVMe. So I got NVMe or fabrics. And it's funny, because if you take the software stack you can get in Red Hat or SUSE, you can actually put tape drives on the back end of an NVMe or fabric solution, because the way it's architected, it's virtualized and abstracted away, which is not a performance solution, but that's something that you could do if you're highly motivated. But we're seeing performance improvements by just moving to the software stack and SPDK in the target. And then the backside of the storage array, once you start moving from SAS and SATA SSDs on the back end of the array to NVMe drives, you're going to start seeing the next step in improvement in performance. So we'll talk about these today, and I'll turn it over to Claude. The first part.
So I'm Claude Barrera. I do storage strategy for the IBM storage organization. And in the course of doing that, I look at various technologies and how we build those things into enterprise arrays. So this will be the enterprise array view of the world vis-a-vis NVMe over fabrics. So first of all, the topologies that we think about in the enterprise space are becoming increasingly mixed. So this is a picture of things that might all coexist within the data center. On the extreme left over here, we have direct attached storage and hyperconverged. Sometimes those are smallish systems. Sometimes in, say, the HPC world, they're great big systems, but you have some kind of interconnect that goes probably nowadays directly to flash. So NVMe is a good candidate there. In the center, we have the all-flash array picture. So there's a shared external storage array. Picture there is all flash with some kind of connectivity to it, to a bunch of servers that are sharing the capacity. So we'll talk about how NVMe over fabric plays in that picture. But the connection, you should think of that connection as a fabric. And then there's hybrid arrays over there on the right, flash and disk together in the same physical box. Increasingly, external storage behind the flash via a different API. So think today SCSI, in the future NVMe over fabric into that flash in the all-flash array picture. And then for archival storage or data lake kind of stuff, or low performance but very low cost, we want a all-disk kind of environment. Typically, you would do that with a different access method, like file or objects. And since it's cost optimized, it's on disk, but no reason that couldn't also be NVMe over fabric too. At some point, just having fewer types of things in your environment makes the world a simpler place. So Brandon made the observation that Fibre Channel is not going away, and it isn't. The colors, as it came out on this particular display, look a little hard to see, but there's actually two light blue pillars there with a green on top. The green is other, the middle pillar is IP, and the bottom pillar, which is really hard to see the difference in color, is Fibre Channel. And since you can't see it, I'll tell you what it says. It says that from 15, 16, 17, 18, we see the net dollars spent on storage attached via Fibre Channel is actually growing. So the chart that Brandon had was capacity. Capacity goes up as things get denser, which is sort of good. but one of the important market measurements is, are people actually spending more money on this stuff? And the answer is yes. So Fibre Channel is not the coolest, sexiest thing in the world. The big, hyperscale cloud guys don't use it in their data centers. But anybody that started building data center infrastructure starting, say, the year 2000 and has been gradually evolving since is on Fibre Channel. And Fibre Channel is not broke. It has a good migration path, and the cost of switching to something else is daunting. Not just the dollar cost, but the interruption, the skill required to do it. So Fibre Channel does what it does today. It's good for commercial data centers, and there we see no run for the doors to go get to some other technologies. So NVMe and NVMe over Fabric, as we see it in enterprise arrays. These little stack pictures here are the enterprise application stack within the server world. So Unix, Linux, Windows, and even mainframe looks a little bit like this. So on the extreme left, that's the traditional SCSI stack that we've been evolving for 40 years or some amazing amount of time. So we come down from an application and usually touch a file system or a database, and there's logical volume managers and SCSI class drivers, et cetera, and you finally work your way down and you go out and you touch a fabric. So there's path length and overhead and latency and queuing and all kinds of stuff going on in that path length. Now, in a world in which storage is disk, none of that matters because the disk is so slow that you can effectively ignore what's happening in that software stack, except for the fact that you're chewing up MIPS and in their servers, and maybe that's not good. But from a performance standpoint, who cares? But put flash in that picture, and now all of a sudden people do care because the basic media is very high performance. I could do quite a bit better, but something's in the way. And when you find out what's in the way, it turns out to be, or at least one of the ingredients is this lengthy path length stack. So two other possibilities. The one in the middle says, modify as little as possible. So I want to sort of surgically go into that stack, pull out what I need to pull out to insert NVMe over Fabric, stick it back in, make it as efficient and effective as possible. So in the course of doing that, we're doing a little better in parallelism and lock management and keeping different applications from contention. But other than that, I'm inserting the NVMe access method as a replacement for what we used to see with SCSI. And then on the extreme right is something really radical, which says, gee, we got this thing, I can do puts and gets to it. Why don't I use that as a memory model and pretend I'm accessing over a PCIe bus, which happens to be very long and spans across the machine room. And you can do that. You can get rid of all this bad stuff like file systems and logical volume managers. In fact, you can even run all of that stuff in user space and not even do a context switch into the kernel. And when you do that, you are really running hard. But the big bugaboo on that thing on the right is the application really has to know that's happening. The application has to be rewritten. And that's a heavy lift. That's asking a lot of the world to say, go back and change all this stuff, which more or less isn't broke on behalf of better performance. You can get something really great. The only people that will move are the people that really care about the pony that's at the end of this heavy road. And those guys today are the in-memory database people. So people like Redis, SAP HANA perhaps, the guys that really lust for extreme performance at the I/O level, and are willing to go rewrite applications so that the app knows, gee, I'm not just running with a couple of 100 gig worth of memory. I've got 50 terabytes of memory, and that's different access paths and different table sizes, et cetera, within the app. So really big modification. So you might ask, and I did, so what's the difference in performance between these different models? So two comparisons. One comparison is the original SCSI thing to the soft modification where I pull out SCSI and stick in NVMe over Fabric. And then the one on the right is the original SCSI thing compared to the radical, let's go reinvent the way applications deal with persistent memory. So the answer when you call up a performance guy and you say, what happens when I do these two different kinds of things and compare them? And the answer, of course, if you've ever talked to a performance guy, is it depends. So when you just sort of really push on them and say, well, give me a ballpark idea of what could I expect in this first comparison over here. And the answer is, well, what's happening is you're improving the path length in the server. You get better server utilization or less server MIPS associated with IOs. And therefore, you could say on a IO-bound application that I'm getting back 30% of the CPU compared to the utilization that I would be using if I were doing this all with SCSI. So what does that say about application throughput? Well, the answer sort of doesn't really say anything at all. If your application is intensely IO-bound, you will see better performance. Exactly how much is not really addressed in my answer here. But you are getting back CPU MIPS, and that's a good thing. So there are efficiencies to be had, and workload performance will be better, but exactly how much better depends on how IO bound you are. And then the comparison on the right, SCSI versus this deal with persistent memory as the way applications run, that can be as big as 5x. So that's an IBM research number. We actually have done some of this in our Zurich lab, and such things are possible, but only with rather profound changes in the applications. So what fabric do I run NVMe over Fabric over? The really good news is I can do this over multiple fabrics, and the most likely near-term customer choice just about anywhere in the commercial space is whatever I am using today, I will continue to use and just run NVMe over it. And that is an immensely good answer. In a couple of slides here, or another next slide maybe, I'll make the point that the less you can change to insert a technology, the more likely that technology is to be adopted, assuming that there is some benefit for doing the work at all. But 2 years ago, at a conference like this, people would have said, this is the big wake-up call for InfiniBand. Everything, all the other stuff is going to go to the curb, and InfiniBand is going to take over the data centers. And when I heard that story, I thought, this is never going to happen. It cannot be. And the good news is that the Fibre Channel people stepped up, and last year, all the analysts that I talked to said, NVMe over whatever your fabric of choice is, and in the commercial space, that's going to be Fibre Channel. So the benefits of continuity. If you have a new technology that you're trying to impose upon the world, and it ought to take over the whole world, and people that never heard of it ought to be using it, that's fine. But if your story for introduction is everything in the stack has to change to use my thing, you will not be successful. It almost doesn't matter how good, important your thing is, because the change in operation, in install base, in skill, the interruption associated with doing it, the diversion of people who are worrying about how do I improve security or how do I improve GDPR compliance and all the other long list of stuff that enterprise operations people have to worry about can't be stopped to say, go take 2 years out of your life and go screw around with this. A much better story is do a very small modification. The perfect answer is no modification at all, which of course probably isn't possible, but change the drivers. Take a 10-minute outage on New Year's Eve and update your driver path. The hardware can have been pre-readied, and that's actually what's been happening in NVMe over Fabric for enterprise arrays. And then at some point push the button and the conversion happens, and the only thing that users knew is that performance got somehow better. And if that's the story, your thing goes in. Now you have a beachhead, and over time, as there becomes an opportunity to put in a new disk array, put in a new application set or new middleware, those can all be optimized around the new capability that exists and the world begins to make progress. That's actually how flash happened in enterprise. We went off to SCSI disk arrays, pulled out HDDs, put in SSDs, and the world got 30% better in terms of IOP performance. Not 5x better, but 30% better. That was good enough to cause the transition to begin to happen. And over time, the arrays got more optimized around flash. The networks got faster. The now NVMe is present. So everything is sort of working its way up. There was no one giant event at which the entire change happened. So the value that we see, so this sort of shows the end-to-end connection. I'm going to do NVMe over fabric from the host through whatever the SAN fabric is that I happen to want to use, down to the storage array, and within the storage array, I've got NVMe probably over PCIe within the array itself. So now I have a complete end-to-end picture, and all the optimizations can continue to happen around that. So with that, I think I'm done and ready for Mike.
Hi, I'm Mike Kieran. I'm a technical marketing engineer with NetApp here in Sunnyvale. I'm going to be looking at some data that we have that tries to tease out what the performance gains are across the various parts of the stack as we implement NVMe. But I wanted to begin with a business rationale for all of this. In particular, as we go to market and work with our customers to find solutions that solve their business problems, we have to be congruent with the budgets and the kind of dollar improvement that they will see. And for that, what we've found works is to identify the high value use cases where the NVMe improvement in throughput and reduction in latency tie to specific business benefits. And so the initial use cases where we're seeing pickup of NVMe initially on the back end are these types of applications that require real-time performance. And the big three would be artificial intelligence, machine learning, which is part of AI, but a distinct domain, and real-time analytics, advanced analytics that are beginning to completely change the way people approach business. So we look, for instance, at something like, could be social marketing, and now instead of just having the feeds, we rely very heavily on the metrics that come back from a platform that lets us know about engagement and syndication and pickup, so that we can make sure that when we're investing in content, that it's actually, that our audience is responding to it. So for us, these types of applications are so critical to the business that they justify the increased investment for NVMe, in particular to reduce latency and improve throughput. So I wanted to break apart then a couple of different aspects of the improvement here. And so we'll look at this in terms of first hard disk drives, then we'll look at NAND flash, and then let's move into what's happening first with NVMe and then with system class memory. I think we're going to see a whole shift here as new technologies come to market, not just NVMe, but for instance, server-based technologies as well. And so what we've done here, we've broken down a couple of the different contributors to latency in the stack. And you can see here that part of it is due to, at the bottom here, the software latency itself. And that's not going to go away. We've estimated that at 10 microseconds. Then we see the I/O controller latency, which does shrink somewhat when we move from a hard disk drive system to SAS-based NAND flash. But what you see is that the biggest shift here is in the drive latency, obviously, as we move from mechanical spinning disk to solid-state media. Now, when we add NVMe, specifically what we see here is that we lose the I/O controller latency aspect of the stack. And so we see the total latency dropping significantly. But what I think a lot of the industry, a lot of customers are really looking at is what's next. And this is where we see, as you may know, NetApp last year, or in 2016, actually acquired Plexus Store, and has recently made some announcements about new software at the server side that's going to even further improve performance. And this is where we see NVMe over fabrics with system class memory really driving things down into the low microsecond area. So that's a little bit of future combined with what we're shipping now. NetApp has already made some announcements around its plans to come to market with the Plexus Store, what is now being called Max Data technology. Claude referenced this briefly, but I think it's helpful to understand exactly what's going on under the hood and why this is so important. Essentially, when we move from the SCSI world into the world of NVMe, we're actually taking that command set and encapsulating it in a fiber channel frame. And that is what enables, I think one of the points that Claude made really nicely was that if you go into your install base and say, rip and replace, this is, go get the forklifts, they don't respond well to that. Whereas if, you see how an older technology can be subsumed into and can gain performance advantages when you merge it with new technology, I think that's a pretty good example of how those two fit together. So this is the part that is the NetApp Vision. And again, I don't want, it's not a commercial for NetApp, but I do want to emphasize the shifts that are occurring in the overall architecture here. In particular, we see, traditional architecture here with the CPU in the server, another CPU in the controller, and we've got typically for, high availability systems, we have the host bus adapters and switches and directors in the middle. Now what we see at the beginning here is solid state drives attached to the controller via NVMe. And everyone I think is asking the same question: how do you tease out the various parts of performance improvement here? And I have some data from a recent DeMartech lab report that I'll use to add some more color to this in a moment. Then the next stage, of course, is persistent memory. And why this is significant is it's at the server. It's not something that's attached to the storage controller. And for a lot of customers, this is going to require some learning and some adjustment, because they're going to be saying, well, hang on a second, this is software that we run on a per instance basis in the server, and it gets like huge performance benefits? Yes. So it's going to require a new model and a new understanding of the relationship between the storage controller CPU and the server. And then the next or ultimate stage would be to take that same storage class memory and use it as a cache in the storage CPU and have it being used for direct memory access in the server. So this is basically the way we see this playing out. Again, pretty agnostic here. We did come to market first with NVMe over Fibre Channel, but we really are open to all the different flavors. We know that InfiniBand is important for some customers. We know that Ethernet is absolutely going to be a requirement. The whole rocky world is one where, we don't pre-announce things, but it's reasonable to expect that NetApp will continue to expand its product capabilities in this area. So this is where we wanted to understand, well, where does the performance improvement come from? And in particular, when we move from the SCSI part of the stack to NVMe over Fibre Channel, this is where we are seeing the increase. In particular, you can see that we have the relatively flat shift in latency until we really see where Fibre Channel hits the wall. And we've removed the numbers from this for competitive reasons, but this is where Fibre Channel protocol, i.e. SCSI, just cannot compete with the NVMe over Fibre Channel. So in peak IOPS, I think this is a question you were asking, Claude, we see approximately a 50% increase, but your mileage may vary. Part of this shift, of course, is new technology. This is probably second hand to some of you, but we're moving to a world of namespaces, And I want to mention, by the way, that the change from ALUA to asymmetric namespace access, ANA, that is something that is in process. And I'm kind of proud that NetApp has played an important part in leading those technical specifications, my colleagues, Fred Knight and others, because it's really important that we provide standards so that our customers can update these to these new technologies. And recently, you know, the ratification of ANA was, I think, an important step in that process. So let's look at just a little bit of data. Again, this is not about a specific NetApp product, but we did these tests on an all-flash array A700. Newer tests have been done on the A800 that haven't been released as yet. But the configuration is a pretty standard one here. Emulex HBAs, brocade G620 switch, 32 gigabit fiber channel, and then, as I said, the NetApp AFF A700S. And what we're seeing here is that specifically for big data analytics, IoT, AL, deep learning, and so this really accelerates applications in a way that is economically significant to companies, especially for enterprise workloads. These can be things like Oracle, SAP, SQL Server, and others. They're available to immediately take advantage of these performance gains. So this is the test data. These slides will be available for you to examine in more detail, but what we tried to do to have real world, fair, comparable data to present is you'll notice that in the top left, we're charting with random 4K reads. Over in the top right, it's sequential reads, 32K reads. Down in the bottom left, random reads of 4K. And then in the bottom right here, sequential reads of 64K. And what's really interesting to note, these are single node A700s using the standard Demartech methodology, where you really are seeing these performance gains. And I think these are the 40 to 50% range that you'll see in marketing materials, are where FCP hits the wall and NVMe allows that much greater performance. So that's it for my presentation. Now I think we're going to have Brandon wrap it up by talking about how the performance and improvements at the initiator are key to the whole process. Brandon?
I'm back. Just to cheat back. What's interesting here, and what I learned about when I see these charts from the storage guys, is what they're really doing is they're showing where the storage system saturates. And when you have a much more efficient software stack, like NVMe over Fabrics and NVMe, it runs faster because you have, more MIPS, more CPU capability to throw at the storage workload, which is great. So we talk about on the server side, and we're now, so we just isolated the storage system. The way we isolate the storage system is we have one storage system, lots of servers. The way you isolate the server side is you have one server, one initiator, and several targets. And so in terms of just testing and do comparison, we're going to use the exact same hardware, run SCSI over Fibre Channel and NVMe over Fibre Channel. We're going to use two targets, one initiator, two targets. And here are the details. We're also going to use bigger workloads, right? 32 threads, 32 queue depths. The threads is important. NVMe is designed to be multi-queue, tons of queues, and that means each thread is a queue. If you run one thread, it's not really taking advantage of NVMe. So we're running 32 by 32. This is a standard workload you'd see in virtualization systems, database systems, and stuff like that. What we see, and we shared this data publicly in the past, is that the lean stack delivers more IOPS with less CPU. Now this is done on SLUS 12SP3. In Linux, there's been a movement to make actually the initiators run faster by moving from single queue SCSI to multi-queue SCSI, and that's actually included here. It's not, for this product set, it's not that big a deal. And so you see higher IOPS, over 1 million IOPS, when for NVMe or Fibre Channel, when SCSI over NVMe or Fibre Channel delivers over 1 million IOPS, about the same CPU. SCSI over Fibre Channel, lower IOPS, about the same CPU. If you just do a ratio and you go through all the different things, 16 by 16, 8 by 8, 64 by 64 for queue depths and all that stuff, it's about a factor of 2. It's interesting, when we did our first announcement 2 years ago with testing we said, hey, it's about a 55% improvement in performance, 55% latency, and it's actually held true for 2 years that it's about a factor 2 every place we look because you get a much better CPU utilization. And in the Linux stack, which has a full NVMe driver stack, that gives you, a much more efficient, complete solution. So part of this is, and part of the reason why we get the performance improvement is the NVMe Express group has a Linux group inside of it, and we actually wrote the code. They wrote the code, the really smart people wrote the code to replace or run a new software stack next to SCSI. And so it's a brand new stack all the way down to this disk drive. And this includes multipathing. That's where a standard that we talked about here a second ago, ANA, actually comes from the NVMe Express side. It's comparable to a Lua and SCSI if you know what a Lua is, but it gives us all the different things. And this is where we see performance. If I go to the next one, everybody asks, okay, what about latency? So this is the time it takes to complete 32 times 32 IOs. And once again, you just get, it's a shorter path through the software stack. Shorter path through the kernel. Less context switches, all those good things. And then if you run this with SPDK, and we had sessions on the Storage Performance Developer Kit yesterday, you can get better performance on it. If we take this back to some workloads, right? And we're putting together more and more data as these storage arrays come to market. But if I just compare some different workloads, right? So 4K random reads, 16 threads, 16 queue depths, that's kind of like OLTP. If you look at OLTP, it's kind of like that. This isn't a full TPC benchmark and stuff like that, but it gives you an idea. You get much better IOPS, almost 3 to 4 times better IOPS when you run it with NVMe or Fibre Channel versus SCSI or Fibre Channel. And the reason why we're using Fibre Channel here is I can run both protocols independently on the same fabric, and I can get really apples-to-apples comparison of what's the benefit with NVMe versus SCSI. That side, the solution was it was bound on the server side, and so once I moved to NVMe, I can get more CPUs, I can run more applications, and I get better performance. Data warehousing. This is when you start seeing 64K block sizes. In fact, you probably see all the way up to 256, 512K block sizes if you look at Microsoft, other types of workloads, and you get better throughput, just because you can handle the IOs much more efficiently. And if you just look at latency, and this is back to 4K random reads, 8 threads, queue depth of 1, and so that's 8 threads running in parallel, we get about half the latency with NVMe over Fibre Channel. Now, part of this is from the storage system, part of this is from the initiator. Mileage is going to vary. It's going to vary based on your storage rate. It's going to vary based on your initiator, your OS, because not every OS is going to be as efficient as this. But this is some of the numbers we've seen. So hopefully we've addressed some of the biggest questions I get in terms of NVMe or Fibre Channel. Why do people want to move to NVMe or fabrics? Why is NVMe important in the data center? And hopefully we were able to share some really good performance data. Open up for questions. So it's funny because when we first started testing SCSI or Fibre Channel versus NVMe or Fibre Channel, we get latencies in 70 microseconds for SCSI. And that's because SCSI was set up on a single queue in Linux. Now VMware and Windows were multi-queue already. But now Linux has added the feature to multi-queue in the OS. And from a drive point of view, that can help. From a Fibre Channel point of view, depending on implementation, it may help some, it does help some, it doesn't. Because the Fibre Channel guys, we've always been running multi-queue already. That's how you access enterprise arrays. But if you just do some basic benchmarking, you can show that adding in multi-queue in SCSI does provide a performance improvement. But what our testing shown is NVMe over Fibre Channel or NVMe provides even more performance. And it's because, multi-queue gets faster, but you still have a very fat stack, and NVMe is a thin stack, it's an efficient stack.
And these numbers were?
It's a combination, multi-queue, single queue. Part of the stack is single queue, part of the stack is multi-queue. You'll see when you look through all the data, you get kind of variations based on paging and stuff like that, on the queue sizes and stuff like that. So that's why I looked at the average of it. So if you look at the middle one, you have NVMe or Fibre Channel is starting to use more CPU, but I'm cranking out over 1 million IOPS. Then as I go faster, NVMe or Fibre Channel will actually hit line rate first. And so once you hit line rate first, then, and that's why we put sometimes we put 16K on this, because then you can see obviously, because once you go to 16K, 32K, you stop seeing all the, so much advantages. But yeah, that's the difference there. So really, your question is, if repeat back, and this is one that I'd love to turn over to the panel for discussion. Is basically, okay, I've got NVMe or fabrics. I want to do it. What fabric should I think about, right? And I've got all these different options, and we got different architectures, right? So we had a really good discussion with that on NVMe or fabrics transports yesterday. Oh, okay. But since we have experts up here, we'll turn this open to Claude. Start
So
out.
the simplest answer I would give to a client that asked me that question is, go to your current fabric vendor and ask what their plan is for NVMe over fabric. And every single one will have one, and every single one will tell them, okay, here's where your current generation of equipment is. Here's what steps have to be taken to adopt NVMe as a protocol over that fabric. And that will almost always be the path of least resistance in terms of upset to your current operation, work to be done, time to result. If you have a empty data center, this is a greenfield application. There's no install base at all present. Then it probably is legitimate to say, do I want to be on iSCSI or InfiniBand or Fibre Channel or something else? The answers there usually come from what application set am I trying to run? What skill model do I have in my environment? So the hyperscale cloud guys, when they all got started, they had empty data centers, and they all said, we want a single fabric technology for everything we do. We don't want to go screw around with a separate network for storage, and none of them have Fibre Channel. So they all did IP, and that meant iSCSI, and they had to goof around a little bit to create management stacks of their own. So those things exist in the hyperscale environments. But there was work to do, but as they did their own arithmetic, they thought it was that was a valid comparison. So the question of, do I get a little more CPU efficiency with iWarp or something else? That's going to be a relatively small piece of the consideration when you say, I'm going to build an entire operation. What do I have to consider?
My answer is what Claude said.
So yeah, I'd like to point out that both these companies do have NVMe over InfiniBand's products in market, right?
Yeah, we do.
Yeah, and so there are some products out there with InfiniBand because that was our early market. It's an easy market to go get. Then NVMe or Fibre Channel is coming out. And of course, a lot of people are talking about Rocky and RDMA and different solutions there.
So yeah, the InfiniBand solution is scary fast, and there's a class of customers that wanted that, and we built that. Fibre Channel was the natural next protocol for us because SAN is just so key. I know a lot of people think of NetApp as the filer company and as a NAS company, but actually SAN is where the fastest growth is for us. And so we are currently working on expanding support to other protocols.
So the typical conversation that I have with clients that ask that question is, well, when they say, well, what do you guys think? I say, well, what are you considering? And usually they say, well, we're considering using what we have today. And then I say, what a great choice.
For the discussion we had yesterday, the panel we had yesterday, we talked about RDMA. Fibre Channel is the one that's out there most prevalently right now in terms of arrays and volume and enterprise customers. RDMA is going to be very important. You have iWarp and Rocky, both are great options there. You're going to see that probably in the rack scale. Cisco has some really good comments about how that will scale past the rack and stuff like that. And the next one, I don't know if you were alluding to this, is NVMe or TCP, which is a new standard, right? So I'd like to get your guys' thoughts on NVMe or TCP.
I think we have to look at this historically. When you look at how companies went from local area networks to wide area networks and the skill set that they brought with them in their IT departments, it's a big leap for some of them to go to Fibre Channel. And so we see NVMe over TCPIP as being an important pathway for companies that obviously want the benefits of NVMe over fabrics, but don't want or need the complexity or cost of Fibre Channel.
Yeah, I'd agree with that. When one statistic I didn't have an exact number for is if somebody's building a new data center today, what percentage of those guys deploy Fibre Channel as opposed to something else? And I don't have perfect numbers, but there's not a whole ton of brand new first-time customer data center builds that go to Fibre Channel. The new current cloud model that everybody sort of looks at is IP and TCP. So that tends to be a growing thing. If you couldn't see the numbers that I had, but that actually does grow in terms of spend faster than Fibre Channel. Fibre Channel does grow. But it's current existing Fibre Channel guys that are using it. As far as NVMe over TCP, I've actually seen some technology demonstrations that look very encouraging. It's a little bit still an open question as to how much changes in the end-to-end management of storage performance when you make that change. But it's another good choice to be adding to the list, and over time we'll get more information about exactly how good it is.
Just a note from the NVMe Express officially, the standard's not done yet, but it should be soon. It's the worst kept secret at NVMe. So on the target side, it does help to use SPDK, so we do get performance stuff there, but just the stack itself is so much shorter. You do get better performance. I don't have a breakdown of the two there. But yeah, that's a valid point that we did use SPDK in the target for that implementation. So if you're going to say, so if your question is what the network can do, right? So if you look at the three technologies, Ethernet, InfiniBand, Fibre Channel, the three things that control latency and performance are not different between them, right? The things that control latency and performance between the three protocols are SerDes, PHYs, and optics. There's some queuing, there's some interrupting, but you can fix that with SPDK and other stuff as well. So those three technologies are really physics. They get better on the regular scale. So between the three technologies overall, you're not going to have better performance on one or the other. And we've published data showing that. So that's something. As we start moving to new memory models, right? SCM and PMEM, right? Those are the big things there. The question is, how does NVMe or fabrics fit in that world? When I have 20 microseconds latency moving across the fabric and 5 microseconds latency in the server, how do those live together? So I'll go to Claude first on that. So is that a good way to ask it?
Yes. Well, once you go to the memory model picture, a lot of things have to change. The application environment changes. The entire software stack is very different inside the server. That said, Fibre Channel remains a okay choice. It may not be completely optimal. It's a open question whether clients making that leap are going to go to new fabrics to do it. One possible avenue for the industry to go is as I make those changes, not only am I changing the application stack, I'm changing the way the server itself is built. So the motherboards will have, server class or storage class memories on board. The applications are different. The middleware is different. The server is different. Maybe what the customers do when they deploy applications that really need that structure is they create a little greenfield element within their data center, and that can accommodate a new fabric. So that's a possibility.
I don't have a lot to add to that. I think that's a good answer, Claude.
You answer first next time.
Okay, good.
Well, if I was to kind of repeat a couple things that Claude and Mike said earlier is that as you start moving up the stack, like SCM and PMEM and these different types of technologies, now you're starting to change the application. And once you start changing the application, that takes a lot longer to actually get adopted. And how that's going to evolve is going to be completely a lot different than just putting NVMe in the right. NVMe, the Fabrics model that we've shown today, basically it's a plug and play into the block layer of any OS. And so Linux, it was built by the Express guys. Windows has it for the NVMe driver. VMware announced it as a driver, as well as announced over Fabrics yesterday. And so is a future. So all these things, but they plug into the block layer. Once you pull out that block layer, and I can go back to Claude's later showed that, then you're talking directly to the application. You start removing those pieces of latency. And a lot of applications talk directly to a block layer anyhow. But that's when the change is going to be happening. I'm going to get much better performance. And that's the challenge with PMEM today, right? So the PMEM solutions come to market. There's a storage model for it, and then there's a memory model. And applications aren't designed with persistent memory in mind. So it's a different thing, and it's going to take a while to adopt, but it's very interesting. So I'm going to ask Mike, when do you think PMM is going to hit the market? Be used.
Yeah, actually, I did want to address that because the obstacles are huge, and NetApp is investing heavily in this area. We acquired Plexus Store and have announced we're bringing this Max Data product to market in the 2019 timeframe. So in answer to that question, but there has to be a reason why a company would go to the trouble of licensing the software, because it's server based, it's on a per host basis, and why they would go to the trouble, as Claude points out, of rewriting the applications. And the answer turns out to be speed, just blazingly fast speed. There's a huge speed bump that's possible with persistent memory. And I think that's, for the applications that require it, that's where companies will make the investment.
Yeah, what Mike said. The only thing I'd add is that the guys that will go down this path first are the in-memory database companies. So, Redis and HANA and a few others. They're the ones that will most immediately be ready to adopt that model and see the benefit.
And when people say, well, what is the benefit? The types of use cases that we are seeing out in the field are, let's say that you have all of your CRM, in HANA, and now what's happening in real time is that customer is on a website looking at buying something. Where the value comes in is if there's a whole new set of advanced analytic tools that you can apply in real time that shift some aspect of the offer or the language or the presentation so that you shift that from a maybe to a yes, where you trigger a sale. That's where the value ties in.
Additional questions. We have time for like 2-3 more questions. Going once, going twice. Sold. So contact information will be in the list here. So myself, Claude, and Mike, all happy to answer additional questions for you guys in terms of how NVMe and NVMe Fabrics are moving into enterprise arrays. The next session will be NVMe and over appliances, headed up by Jeremy Warner from Toshiba, and we'll kick that off, I think, in about 20 minutes. So you have a break. Thank you.